Welcome to the very first video of this subject, theory of computation. So, in theory of computations, we study about the different computational devices, their power, their limitations. But how do you compute in a computer system? You run a program to compute. That's what you do. And what is a program? A program is basically the algorithm written in any programming language. Okay. So what is a function? Function is an abstract notion that tells about the mapping and algorithms tells about how to obtain the output for a specific input. That a function is just a mapping between domain and range. It's just a mapping. So you can define functions you can define as many functions as you want. But it's the algorithms, which is the step-by-step procedure, that algorithms will take the input and it will generate an output by going through a procedure. So you can have as many functions as you want. You can define as many functions as you want. But can you give the algorithms for all those functions? The answer is no. You cannot have algorithm for all of those functions. Look at this. They are not computable problems and they are computable problems. So in place of function it is saying problem, referring to function as problem, whatever. So there are many problems or functions that are computable, meaning there exists some algorithm that computes an answer. Similarly, non-computable problems or functions, there exist for which there is no algorithm. There is no algorithm that can be used to solve it. We are entering into the subject with a question that for what functions we can have algorithms. So every algorithm computes a function, but out of all possible definitions of functions, you cannot have algorithm for each of the functions. In fact, out of all functions possible, only a tiny fraction can have algorithms. So what are the class of functions which admit algorithms to compute them? For what functions we can have algorithms? For every function, you can have something called as graph of the function, which is a set of, this is a comma b such that b is equal to f of a. So this is a set of tuples where a is the input and b is the function of a. Basically a is the input and b is the output. Every function is associated with a set. Every function is associated with a set, which is this. So what is this set? This set is A1, B1, A2, B2, A3, B3, so on, AN, BN. All of this element is the input and the output, domain and range. What about set membership problem for this set? What is set membership problem? If you have a set, let's say, if you have a set S and you have an element E, so whether E belongs to S or not, this is the set membership problem. If you have an algorithm for set membership problem of graph of F, what does this mean? What does this mean? It means that you will have an input, let's say x, y input. It means you can determine whether x, y belongs to graph of F. What is y here? What is x here? The input. And what is y here? The output, which is f of x. So if you have an algorithm for set membership of graph of F, does not mean that you have an algorithm for f, because B is f of a, because B is the output. So if you have an algorithm for set membership of graph of f, you have the algorithm for the function. And if you do not have an algorithm for the set membership of graph of f, then you do not have an algorithm for that function. Okay, so this is the takeaway. If there is no algorithm to solve the set membership problem for the set associated with the function, then we can conclude there is no algorithm to compute f. If there is no algorithm to compute f, then there is if there is algorithm to compute f, then there is an algorithm to solve set membership problem of set graph of f. What we are trying to establish here is this, that the problem that for what function, whether you have an algorithm for this function or not, is equivalent to the problem that whether you have an algorithm for set membership problem of the set associated with this function, which is graph of f. So we have establishing the equivalency here. And why do that? Why do that? To reframe our question. To reframe our question. The aim was to get whether for a function there is an algorithm. And now we are reframing it to this, that whether for this set you have an algorithm for the set membership problem. From now on, going forward, we will be talking about set membership throughout this theory of computation. Now we will be concerned with set membership problem. Why? Because sets is more fundamental and simple. And in the next video you will see that not only we have simplified simplified the initial question to set membership problem. In the next video we will see that we will even restrict those set to be the set of finite strings.